Earth's moon. The moon may have shielded early Earth from the sun, protecting our atmosphere. The early Earth would not have been a good place to be hanging out. First, around 4.5 billion years ago, when Earth was just a hot, squishy new formed planet, Theia, an object the size of Mars, this is what the theory says, slammed into Earth, sending chunks flying out into space and heating Earth to thousands of degrees. This is by Michael Starr, Science Alert. Kindly support my Patreon account because YouTube has again demonetized my channel. The daily posts are 5 videos daily, and they are totally different from what I have on my YouTube channel. Thank you so much for your support and that you find all my content so interesting. You'll find the Patreon account details in the description box below. Scientists have published this in Science Advances. So what was going on? Then around 4 billion years ago, the solar system was enduring a period called the Late Heavy Bombardment. That's when asteroids positively pummeled the terrestrial planets of our inner solar system. Mars, Earth, Venus. Under this attack, Earth remained hot and its surface molten. In the meantime, the sun, although much dimmer and cooler than it is today, was going through its terrible toddler years. It lashed space with violent, powerful flares and a wild solar wind. And under these conditions, it's a wonder Earth managed to retain enough of its atmosphere to evolve into a world hospitable to life. We may in fact have Theia, early Earth that is, to thank at least partially. Those chunks of Earth it broke off went on to form the moon, as the theory goes, and new research shows that the moon's magnetic field could have shielded Earth from the full brunt of the sun's rage. So as the moon was being split from Earth and flying off, as we can understand, they still had the same magnetosphere. The moon seems to have presented a substantial protective barrier against the solar wind for the Earth, which was critical to Earth's ability to maintain its atmosphere during the time. This is what physicist Jim Green explains. He's a chief scientist at NASA and the lead author of this new study. He says, we used to think the moon was a more or less lifeless chunk of rock. It doesn't have a magnetic field now, so we just assumed it never had one, since it's so small and may not have maintained the dynamo effect required. But when we sent astronauts up there in the 1960s and 70s, the rocks they brought back showed evidence of magnetism, proof that the moon once had a magnetic field much like our Earth. Earth's magnetic field is a result of a dynamo, a rotating convection and electrically conducting fluid that converts kinetic energy into magnetic energy, spinning a magnetic field out into space around our planet. That fluid is Earth's molten iron core, so the theory says. Now, when it was newly formed, mounting evidence suggests the moon was also warm enough to have a gooey center, a molten iron core of its own. Scientists believe it was able to maintain a magnetic field at about 1 to 2.5 billion years ago, when it cooled to the point that the iron core solidified. Green said it's like baking a cake. You take it out of the oven and it's still cooling off. The bigger the mass, the longer it takes to cool off. The Earth-Moon relationship in those early days was a lot closer than how it is today. At about 4 billion years ago, the moon was just 130 kilometers, that's 80,000 miles away, around a third of its current 238,900 mile distance, so it was a lot closer to us, you could understand. Earth was spinning faster then as well. A day was just only 5 hours long. As the planet's rotation slows, the moon recedes at a rate of 3.82 centimeters, that's 1.5 inches a year. It's an ongoing process, so as we can understand, our moon is moving away from the Earth at 1.5 inches a year. Green and his team wanted to know how the moon's magnetic field would interact with the Earth's under those earlier conditions, so they designed a computer model to simulate this. They found that the magnetic fields of the two bodies would be connected via the poles. This combined magnetic field would at times have shielded the Earth from having its atmosphere stripped by the solar wind. There could also have been some atmosphere exchange. Recently discovered evidence suggests that the moon had an atmosphere of its own 3.5 to 4 billion years ago, due to volcanic activity held in place by the lunar magnetic field. But nitrogen found in the lunar regolith has puzzled scientists. It must have been delivered from the outside, they say. The team's simulation suggests that Earth and the Moon could have exchanged atmospheric gases, offering a solution to the puzzle of the new lunar nitrogen. Those simulations indicate the two magnetic fields remain joined up until about 3.5 million years ago. It's a very neat finding that matches up with the timing of the lunar atmosphere as well as the strength of the magnetic field, which was previously found to have peaked about 4 billion years ago. The team hopes that new samples obtained in lunar missions will provide more information. Of interest are regions in permanent shadow at the poles. They may retain oxygen and nitrogen nicked from Earth's atmosphere that may have been destroyed by harsh solar radiation elsewhere. This is interesting because it shows the conditions for habitability may rely on a lot more than a certain kind of a planet, rocky, at a certain distance, not too hot, not too cold, orbiting a certain kind of star. Other recent research suggests that the presence of a gas giant in the same system could be crucial too because of its gravitational influence on both the planet and potentially hazardous objects in the outer solar system. Now, working out which of the Earth's and solar system characteristics have played an important role in habitability will help us narrow down where to look for extraterrestrial life, but learning about the Moon is important for its own sake as well. Understanding the history of the Moon's magnetic field helps us understand not only possible early atmospheres, but how the lunar interior evolved. This is what a NASA astronomer Deputy Chief Scientist David Draper says. He says it tells us about what the Moon's core could have been like, probably a combination of both liquid and solid metal at some point in its history, and it's a very important piece of the puzzle for how the Moon works in the inside. This was published on Science Advances. It's on Science Alert by Michael Starr. Please leave your comments. Thank you.